Welcome to the video. In this video, we are going to look at problem number 26 of chapter 22. If you have not watched the video on a summary of circular charge, please do that first. In this problem, there are two circular charges with opposite signs, and we'll look at them one at a time. The first one carries a positive charge. It occupies the second quadrant, and the angle extended by the arc is 90 degrees, or a quarter of 2 pi. So, for that first arc, the charge density is lambda being equal to Q divided by R theta, where theta is the angle extended by the arc. The direction of the electric field created by that first arc at the center of the arc will be along the line of symmetry. And since the charge is positive, the direction will be away from the charge. And the magnitude is just the expression that we obtained in an earlier video. And once again, that angle theta here is just the angle extended by that first arc. And we'll repeat the calculation for the second arc. And because other than the sign, everything is the same, so we can pretty much repeat what we did. Now let's add the direction to the expression for the electric field. For that first electric field, the direction is along the southeast direction. And for the second electric field, because the charge is negative, the direction of the electric field will be pointing southwest. So we now have two vectors, E positive pointing to the southeast and E negative pointing to the southwest. These two vectors have the same magnitude, but of course the directions are different. This is a situation that we have seen before, and part of their components will cancel. And in this case, it is the horizontal components that will cancel, and therefore the resultant net field will be along the negative y direction. And the magnitude of the net field will be the addition of the two surviving components. The magnitude of the component that matters is just the magnitude of the vector followed by cosine of the angle in the vector addition, which in this case is 45 degrees. And therefore, we have the following expression for the magnitude of the net electric field. In this expression, what's in the parentheses is the magnitude of the vector. And together with the cosine 45 degrees, we have the surviving component of the vector. And there's a factor of 2 in the front, and that's because we have a total of 2 surviving components. Altogether, we have the next expression. At this point, we can invoke a trig identity to simplify that expression that contains both the sine and the cosine. And so we will have a final expression for the magnitude of the net field. And since in our expression, theta is equal to 90 degrees, sine of theta is equal to 1. But of course, in this final expression, that angle theta must be expressed in radian, which is a quarter of 2 pi, or pi over 2. And that completes this video.